So, hello everybody. My name is Luigi, and I am the founder of Oikla, a tech company that specializes in psychoacoustic um, software that aim to increase the perception of sound without making it dangerous for your hearing. But anyway, today I'm about to present to you a project of mine that I worked back in like a long time ago, 2015. It's a project that I really enjoyed working on, and I think it's time to showcase it, and I think the time is right. So, what I'm about to present to you, here we go, is mind match audio, basically revolutionizing reading experience through real-time sound and synchronization. So, I have a little confession to make. Um, basically, I started this project because I used to hate reading, and I loved the sound and music. So that passion led me to wonder, what if we could bring sound into the reading experience to make it more immersive and enjoyable for people like me? Imagine stepping into a story, not just through words on a page, but with an experience that immerses you in sound in real time. And so basically, the concept is to make sure that when you read, sound is synchronized based on your imagination. And so let's look at why reading as a medium needs this kind of transformation. Whew. All right. So unlike movies or video games, in reading, the visual is hidden within the reader's imagination, which makes it incredibly challenging to synchronize sound with what the reader is imagining. Our goal is to bring the hidden visuals to life with sound. And that's why syncing the audio is so important. We weren't just aligning sound with text on a screen, but with the experience unfolding in the reader's mind. So a century ago, the movie industry changed completely by adding the sound to visual, creating the immersive experience we enjoy today. But reading has stayed the same. And I'm not talking about the audio book. That's a totally different thing. The reading experience, as we know so far, it's silent. And when we read, we rely entirely on our imagination, which is not necessarily bad at all. It's just that it's in our mind. So what we see and what we hear stays basic. We create it ourselves. And we create the atmosphere and depth. But why has reading stayed silent? And what does that cost us in terms of engagement and emotion? Today, I would like to show you how we can change that. So the project that we worked on rely on basically using eye tracking technology and real-time sound. So basically what we did is we used eye tracking to map where the reader is looking as they move through the text, but just matching sound to a location on a screen isn't enough. The real breakthrough is matching the audio to what the reader is imagining, and that's where the real challenge is. What you read, it takes time for your brain to process. You land your eyes on a word, understand it, and then picture it in your mind. Our technology takes this delay into account using smart algorithms that basically predicts. We have algorithms that understands the word difficulty, word frequency, context of what you're reading, and based on all of these variables, there are slight delays that are applied when you land on a specific word. Because the problem is, if we trigger a word a little too soon or a little too later, we might break the magic that synchronization will bring. When we watch a movie or when we play a video game, sound is perfectly synchronized with what you're saying, which is in a way a pretty straightforward way of synchronizing what we see with what we hear, right? Basically, when we work in post-production and we work on sound design, it's fairly simple to align a frame with sound. But when it comes to the reading experience, it's much more challenging because we have no reference as to when we need to play a specific sound in order to be matched with a specific imagination. So our technology, the most challenging part was to basically make sure that we could play the right sound at the right moment, so that the imagination would be the reading experience wouldn't be the sound wouldn't distract the reading experience at all. So in this way, the audio syncs perfectly with what the reader is imagining, not just where they're looking. For example, if the reading is about a storm, you'll hear the wind and distant thunder at exactly the right moment, making the scene feel real. Anyway, I also want to tell you that the talk is about telling you a little bit about this project, and unfortunately, 17 minutes are not enough to explain all the work that has been done in this project, as it will take me more time to explain a bunch of things that probably are going to be a bit boring, because we're talking about the reading, how we read and how the brain processes reading, how the eyes moves, and so on, which are a bunch of challenges that we had to overcome in order to make sure that this synchronization happens. Because to trigger sound based on a location on the screen is fairly trivial. You have X, Y, and then if the eye strike this X and Y position, you trigger a sound. And I must admit that it was way more complex than that, and it required us to understand reading patterns and much more than that. And that's all. So anyway, the next slide is about the demo. I thought that perhaps the best way for you to understand what we did is for you to actually see what we made in the first place. So I'll walk you through that. So here we go. We have a demo. And before we get into the recorded demo, let me set some expectations. You'll see how the system triggers different sound based on my eye movements. This is obviously a pre-recorded demo, so I'm not going to read it live. And remember, the audio is synced with my gaze, not yours, as you watch. You also see a transparent circle on the screen showing where my gaze is in real time. So you'll see basically as I read through, you'll see basically a circle that shows where I'm looking at. You can try to follow it if you want, and I encourage you to do it. Even though my reading pace and obviously is going to be different than yours and so on. But I still encourage you to try and follow so that you can see how audio is triggered and how the soundscape change through the story and so on. And yeah, just focus on how smoothly the sound fits with the reading. This is what makes this reading experience immersive, I would say. Okay, so let's take a look. The first thing I want to show you is a couple of things. This is definitely the way we designed this reading experience is very different compared to your traditional reading of stories, and there are specific reasons as to why we designed this way. Anyway, let's dive in really quick. So the first thing is, as soon as we start reading, we only are presented with two lines, all right, the first and the second. So as I read through the story, you can see this little circle there, right? As soon as I get to the end of the first line and I am going to reach to the second line, right? The third line appears. Let me walk you through. As soon as I get to the second one and I go from the second to the third, what happens? The fourth one takes place to what it was the first line. Okay, and when I finish the third line here, and I go to the fourth one, the fifth one is generated instead of the second. When I get to the end of the fourth and I go to the fifth, the sixth one is generated. And you might ask, why would you have such system that is so distracting? And the reality is that we tested it against 100 people. And or you probably don't know, but basically when you're moving your eyes with quick saccades or long saccades, this is the term to say the eye movement. When you move your eyes, you actually don't see what happens. So you go blind for like a very short amount of time. And so because you go essentially blind between this spot and this spot, when the line changes, you don't see the change happening. And this allows us to basically allow you to read without having to click to scroll to the next page or getting distracted from the experience itself. This way, 3 lines, we can just keep going in rotation. So if I keep playing it, when I get to the fifth, I get to the sixth, and when I get to the sixth, the seventh is already generated. So it's basically going 1, 2, 3, and then back on. Anyway, this is just to show you how you should follow up, and if I hope this makes any sense to you. But the idea was that I will be able to read with an eye tracking that looks at my eyes, understand what I'm reading, and basically auto scrolls the next sentence for me ahead. And based on where I'm reading, certain sounds are instantaneous and others are more soundscape and they're more different. Anyway, let's play it and I'll let you guys hear it. I hope you wear headphones. There we go. Play. I think that that's enough for as a demo. So as you can see, yeah, it just keeps on going, but I think it's too long to continue. So let's move on to the next slide. So we tested this reading experience with 100 people, and we found that 93% of all participants found that reading like this enhanced their experience. So that's obviously that was an amazing finding for us. And another test that we did was that it's not just about using sound in a clever way to match the user's imagination and enhance the reading experience for the reader. We also found that by triggering sound at the right time actually makes the gaze duration shorter. What it means is that basically, if I were to play the sound, the thunder sound, when you're about to read the word thunder, if you read the word without sound, it will take you basically longer. And if I play this, and if you were to read the word thunder with the sound, sorry, the word thunder with the sound, the thunder sound, it would take 63% less for you to actually read that word. And what that means is that what we think, we think that basically the reason why that happened is because sound is processed much faster in our brain than reading. So for you to read the word thunder and comprehending and understanding and picturing it in your mind takes longer than just play the thunder sound in your just play it, as that will unconsciously give you the meaning and understanding of what is happening. You don't need to process it; it's just much faster. So if I play the thunder sound at the same time, at the right time, as you're reading the word thunder, because you're hearing the sound and you're reading the first part of the word, your brain understands immediately what is going on and requires less time to process that word. So in a nutshell, basically placing sounds at the right time not only makes the reading experience enhances and provides further tool to basically storytelling, because for example, you don't have to write that it's raining. You can just write about what is happening, and the sound of the rain can provide the context of what is happening. Or perhaps the reverb of a church, right, could perhaps provide how big the space is without the writer writing how big the space was. And again, I'm not trying to say that writer needs to change the way they're writing or there's anything wrong with the old system. I am just interested and excited to see how we can use sound cleverly by matching it with the reader's imagination to enhance the reading experience and to provide new tools as storytelling. And the reason why I kept this project for a long time in my bedroom, as this was my dissertation for university, was because 10 years ago, this wasn't feasible. But today, with eye tracking devices becoming more and more small, and the fact that there are devices now like we can see the Apple Vision Pro and the Quest coming out, I think these kind of applications are way more feasible these days than they used to be. So moving forward, what we think is that we could basically use AI to basically generate sound based on the listener, on the text you're reading. So the audio is generated based on the text, and we can further use machine learning and AI to further understand even better how to personalize the reading experience with this. So I just see a message on Discord, so that's very nice. So just keep in mind that in order to make this happen, I had to basically build a small tailored DAW only for this reading experience, because there's no such thing as the reading experience. They're not tools meant to basically match the reading experience with sound. So I had to basically create the whole DAW just for this particular reading experience. So it was an amazing process back in 2016 to basically read and get the sound and get this this interesting concept, at least to me. And I am very happy that I made it. It took 6 months of hard work back then. But yeah, awesome. So I think this is, using AI to tailor the sound and tailor the experience to the reader even more, because at the moment is made with algorithms that basically makes a bunch of calculation based on how difficult the word you're reading, how long it is, how frequent it is in the English vocabulary, and a bunch of other variables. Then we have delays to trigger sound. Anyway, I guess the last slide is to say a big thank you. This is not my main. I run two companies, and this is more like my little, side love that I used to do. So I still would like to keep it, to move it forward, but differently than what I did with my other companies. So if any of one of you is interested and want to ask me questions, or wants to, collaborate and make this, even further, I'm sure that there will be people interested in trying this. So thank you very much for your time. It's a bit different to be talking in front of a screen. I wish I could be seeing you and I could interact with you, but this is nevertheless great. I hope my talk wasn't boring or not too technical as the others. It will be too long to explain the whole thing, but thank you very much. And I enjoy the rest of the day. Take care.